All right, so from the sake of solving it, did I say G is 10 or did I put it on Earth?
Yeah,
9.8?
yeah. It doesn't
Alright.
specify that, but
So FT4 is 19.6.
yeah. Y3 is 49. Oh, I'm sorry, I didn't know you were going. Oh, sorry.
No,
M Y3. I'm sorry, is 49. I did that one before FT2.
you got Y3
It's the
is
third
down
one.
here. Okay. Is what again?
49, and then FT2 is 24.5. And then the last one we should know is.
All right, so once I have FT4, so it's not that, I now know this value, and that's the only other one that shows up. So F3 is equal to FT4, so that's 19.6 meters. I know FT2 shows up right there. So I know this is 24.5 meters. I know Y3 M1G is, so Y3 is, just had it, there we go, 49 plus, what's the weight of 1?
6 kilograms. The weight.
The weight.
That is 6 times 9.
Yes, okay. So 58.8.
Yes.
So Y1 would be, doing the fancy math there, 107.8. So I now know Y1, which, I know Y1 now. I know F3 already, because that was solved right there. So 19.6 plus point 8 times Y1. That's something.
Can you show me how you got 49 meters?
The 49 newtons here,
Oh, okay.
with Y3s.
Okay.
And this is just back to an earlier question, this is why we need all the equations, is that there's such interdependency. So FT1 is something. Yep.
You have F3 equals F-T4, which equation did you get that from?
Would have F3 equals FT4,
Yeah.
that comes from this one right here. Is there an issue?
I think I just got my equation.
So you come up with FT1, once you have FT1, so there. You now have FT3 cosine theta. In other words, you have the two components of the tension. Because this is gonna, the upward, this is FT3 sine theta or FT2, this is FT1. And it's just a matter of, well, it's like converting from rectangular to polar coordinates. Can you believe when this was a test question, how many people got it? I blamed it on the fact that that was the test where there was a high pitched noise running out through the entire test.
Can you stop, please? It's now.
Yeah,
86.
other than when people flush the toilet, it stopped for about 30 seconds and then it continued again.
Wait, what's the next step after figuring out all of them?
Ultimately, we're trying to find FT3.
Yeah, which after we find the FT3 sine theta and the FT3 cosine theta, we just do Pythagorean theorem, right?
Yeah, that would work. That would give you the magnitude.
The magnitude is 89.65.
I don't remember.
That's just what I was doing. Do we still need to find FT1?
Yeah, we need to find FT1 because that's FT. Oh, I don't have it on the board because
Oh,
no
that's
one
what I
told
was
me.
saying. I just didn't know if you guys said it out loud already.
I didn't hear it.
You're good. So FT1 is equal to 86.24 newtons, and then since we figured out FT1, we figured out FT cosine theta, FT3 cosine theta, because that's equal to FT1, meaning FT3 cosine theta is 86.24. And then those, squared and then added and square rooted is 89.65, which means that, right?
Wait, how did you get that for FT1? I got
Yeah.
105.84.
Yeah,
That's
I
what I
got
got.
Yeah.
For that one?
105.84.
Oh, that's my fault. I'm so sorry. I forgot to add that 19.6. Sorry, guys.
Probably the most common mistake I see when people solve it is leaving that off.
I think I'd fall asleep at this one before I finished it.
Okay.
Say it again?
I think I'd fall asleep before I finished this question.
You would be so jazzed by it that you just have trouble falling asleep?
I think that's not what you said.
My brother, you
It isn't, but I was reinterpreting.
That's nice.
Okay, so I lied. That means FT3 is 108.6. Just 108.6. I'm just gonna round
Okay.
there, right?
Again, I don't remember. I remember the angle. That's about it.
So to find the angle, if that were to be correct, this was there. Oh, it's so, yeah, okay. So to find the angle, you do like arc, sine, and stuff.
Sure.
So since FT3 equals 108.6 newtons, we can take either FT3 cosine theta or FT3 sine theta. I'll do cosine theta. It would be 108. No. Oh wait, no, yeah.
If your brain is about to explode, give us a warning.
No, my brain is so happy right now. The angle,
If you fall asleep, you're gonna miss that.
the angle is, to find the angle, we would do 108.6 cosine theta equals 105.84. And then we divide it by 108.6 on both sides, which is, this one sucks. 108.6, and then we get 0.97. Is that what you're
You're in
getting?
radians? No, that wouldn't be right.
No, I'm in degrees. I haven't found the angle yet.
Oh, did you take the cosine of that fraction or the arc cosine?
I haven't found it at all. I don't know.
Oh, all you did was just do the fraction.
Yeah.
Okay,
Oh my god, the angle is 12.9, right?
close. There's some rounding differences from what I had, but
13?
I had 13 point something.
Yes. Okay, I'm sorry. Did everyone understand what I was saying? Okay. You may want to go to the next slide because it's a lot more work when I have to.
Please don't skip yet.
We basically have, we're adding these two vectors here. The tension in 3 has to be the sum of the other two tensions, but in the opposite direction. FT1 plus FT2 plus FT3 equals 0. FT3 is the negative of FT1 and FT2. FT1 points that way, the negative is in the other direction. So basically adding 105.84, 24.5, they're perpendicular to each other. The angle that we're trying to find and the magnitude. Magnitude, do the Pythagorean theorem. Angle, arctan. What Maram did is she found the hypotenuse and did arc cosine.
Can we use law of sines?
If you wish to use law of sines, go for it. You also could use law of cosines if you want to find them.
See, I don't remember that one easily though.
Yeah, I know, that one is a tougher one.
12.9 degrees. I love physics. Oh wait, there's a second question.
Yeah, so I got 13 points.
I will let the second question, since we basically worked through this, all of part A here, I will let you figure out part B.
Where you going?
Yeah.
You're kind of in a tangent.
Yeah, so I did opposite, oh, cause I'm,
You did arctan of 24.5 over 105.84?
no, I did arctan of 105.84. That's
Ah.
what I did wrong.
So I guess you got a, 77-degree angle?
Yeah.
We're just trying to find FT3. That's the end.
And the angle, yeah, FT3, the vector, magnitude and direction. I think I specifically said was the magnitude and the direction. Any other questions on this glorious problem?
Oh, this is so obvious. Oh, sorry, the second question.
And the reason why I feel like this is very doable is just step by step. You come up with a force diagram, equations of motion, substitution, plug and chug. There's nothing inherently difficult about this, it was just big.
Would you be willing to do another question?
Yes.
Just the big choice diagram, but it.
Oh, breaking that,
The story you give us the diagram, and we have to find the equation of the variable.
so just one step, that's all it is.
So that's the, so, that's the arc cosine.
Arc cosine to what?
0.942, which is, what that is.
You dividing it?
Yeah.
So FT3 is.
So box or a wedge?
And then I did the same thing with sine, and it got pretty close, it's the same.
That's a box.
Oh, it's subtract.
And mass 1, mass 2, I think I did big M, little m.
Yeah.
Rotating the other one, it's the.
Going that way on the track.
And up the rim, or is it horizontal?
Wait, is this motion? Oh. That makes sense a lot.
It does simplify that piece at least.
It does.
All right, so first off, mass 1, this is one of the places where people may have issues. Mass 1 is going, if it accelerates, will accelerate along what line? Wasn't quite sure what the hand gesture there was.
Maybe the horizontal.
Or that way?
Vertical.
Vertical acceleration. That, I'm trying to figure out here,
Up the ramp.
up the ramp. It's either gonna be up the ramp or down the ramp, but I don't know which one. But I know F1, it's gonna be, the acceleration is gonna be along this line right here.
I'm trying to finish my phone.
Unless it's digging into the ramp or coming off the ramp.
It's like,
Mass 2, on the other hand, I don't think they state which way that one's going to accelerate, because that could be accelerating in two different directions. So when we do the mass times acceleration, we will have one of the equations equal to 0 here for mass 1, but we won't have either of these equal to 0.
Measure that accurately. It's like,
Yes.
so I don't think it's right.
How'd you get that?
Now, if we, the force diagram was given to you,
But I think it's wrong because it's
so you had
the
Y1,
differences between that.
F1, big F, Y2, so mass 2, so Y2, W2, I left off W1, and F2, F2, I feel like I've left something off.
No?
That's it?
Mhm.
All right. So we have the direction of acceleration of mass 1, or what is labeled as big M. What is the, how are we gonna set up our coordinate system?
Just before we set that up, how many equations of motions will we have here?
4.
Okay, perfect.
Sorry, I should let you say. All right. So starting from here, it's a matter of coming up with a coordinate system, finding the equations of motion, decomposition, then equations of motion. So I guess 3 steps.
I think decomposition is where I get stuck.
Oh yeah, that's the hardest one here. All right, so coordinate system, assuming up the ramp and away from the ramp. I1 hat and J1 hat. The question is for mass 2. How do you want to break that up? Well, most of the ones that I graded did in the direction of Y2 and F2, so they only have to break the weight up. Perfectly reasonable. There does turn out there's a simpler way of doing it, by keeping the same coordinate system. Because all the hard work would have been done in coming up with the equations of motion for mass 1. But let's just do mass 1 now, and we can do it both ways for mass 2. So what needs to be decomposed?
The weight,
Yep.
and it'll be, because of like, I may be stretching it, but because of where the angle, I think it has to do with like the angle and stuff, it would be, opposite of the friction would be the cosine.
So down the ramp is cosine? Is that what you just said? Weight 1 cosine beta?
No, wait, I thought we were working on mass 2 right now,
No, mass 1.
But yeah,
sorry.
Sorry, what was that? 70?
I just said bigger.
Big, okay. So we're breaking weight up. We breaking anything else up?
Both normal forces. Wait. Just normal forces. Wait.
That was what was confusing, by the way, because the way that the arrow is pointed for normal force 1 on like the sheet of paper, it just doesn't match our coordinate system. It's a little, it's like slanted. It's off. It just looks like it wouldn't work.
For which one? For,
Normal force 1. That was just the way that I did. Unless it was the way that I did.
no, normal force 1 is, I nailed that. It's perfect. Actually, I tried, when I do diagrams like this, I try to make sure that arrows are pointed in the
Oh.
correct direction.
No, would this one have to be pointed? I mean, would this one have to be decomposed?
Yes, it would.
There you go, that's what I meant, not
Which one by 2?
friction too, yeah.
We set up a coordinate system that is parallel and perpendicular to the ramp. Y1 is perpendicular to the ramp.
Is.
So we're good with that, and that. We have to break this up, that up, that.
Okay, I'm just wondering, cause on your drawing, it looks like Y2 is parallel, but then on this, it doesn't.
Looks like Y2 is, it should be perpendicular to that,
Meant to be.
should be perpendicular to this.
Okay.
Some people also get thrown by the fact that the way I drew mask one, I drew it like that, making it look like that's a right angle there, but there's nothing to indicate that that's a right angle, other than, look.
Okay.
If I changed this point right here to somewhere over there, none of the force diagram changes. All right, so we have to break 3 forces up there. Well, as far as the weight goes, that's a box on ramp. So I have wedge, box on ramp. I know if I have weight acting down, then I know in that angle I give it to you. Down the ramp is W sine theta, into the ramp, W cosine theta. So, same thing going on here.
Why?
Why is it sine down the ramp?
Yeah.
All right. Couple ways of looking at it. I'm breaking weight up. This angle here is beta in the case over there. Weight is my hypotenuse, and what I'm breaking up is my hypotenuse. And so I've got a component parallel to the ramp and perpendicular to the ramp. If this is beta, and this is a right triangle, because beta is first the horizontal and weight acts down perpendicular to that. This angle right here has got to be the complement of beta. And I also have a right triangle here. This angle here is beta. So this would, since this is the opposite of beta sine. I skipped, obviously skipped something for you. Where's the issue?
I see it, I just don't remember to do it right now.
You recognize that one of them will be W sine theta and the other one's W
Yeah.
cosine theta or beta or whatever the angle is. Other way of doing it, try to draw it